Good morning, everyone. This is Srinivas, working as an assistant professor in EEE Department of Mlritm, Dundigal. Today, my topic on DC generators. So, before entering into the DC generator, let us know the contents of the DC generator. So, first one is what do you mean by DC generators, and the construction and working principle of DC generators, and various types of the armature winding. Next one is EMF equation and various types of DC generators, armature reaction, the effect of armature reaction, and the reduction of armature reaction, demagnetizing and cross magnetizing conductors, calculation of demagnetizing and cross magnetizing ampere turns. So let us first see the definition of the DC generator. So what do you mean by DC generator? DC generator is a rotating electrical machine which converts mechanical energy into electrical energy. And this DC generator works on the Faraday's law of electromagnetic induction principle. So what do you mean by the Faraday's laws of electromagnetic induction principle? According to the Faraday's laws of electromagnetic induction, when a rotating conductor cuts a steady or a constant magnetic flux, the EMF induced in the conductor, so which is given by Faraday. So the EMF induced in the conductor is mainly because of relative motion between the conductor and the magnetic flux. So next, see the construction of details of DC generators. So let us see the various parts of the DC generators and their functions. The first one is the magnetic frame or yoke. Second one is the pole shoes, interpoles and windings. Third one is the armature. The fourth one is commutator. Fifth one is brushes, bearings and shaft. So let us know the various parts of the DC generators. Let us start with the first one is the magnetic frame or yoke. So what do you mean by yoke or the magnetic frame? So it is a outer frame or yoke, so which is nothing but a protective layer of the entire generator. So it performs certain things. The first one is it provides a mechanical support to the entire generator, and second one is it provides the protection to the whole generator, and third one is it carries the magnetic flux which is produced by the magnetic poles. So next one is the pole or pole shoes. So this pole is a consist of the pole core and pole shoes. So this pole core is attached to the yoke, and this pole core is provided with some field winding. So when this field winding is excited with DC excitation, so when a field current passes through the field winding, so we'll get the magnetic flux. So this magnetic flux is produced from the north pole to south pole through the air gap, and some other interpoles also provided in between the main poles. The main function of the interpoles is reduce the sparking at the brushes. And the next one is armature. The armature is in a cylindrical shape. So armature is nothing but a rotating part of the machine. So it consists of armature core and armature winding. This armature core is provided with some slots. In these slots, armature winding is provided. So whenever a rotor rotates or armature rotates, the conductor cuts the magnetic flux. So according to the Faraday's law, so this rotating conductor, so when cuts the magnetic flux or a constant flux, the EMF induced in the armature winding. So from this armature winding, when it is connected to the external circuit through the commutator, so we'll get a DC signal. Next one is commutator. So the commutator is a cylindrical, so hard run copper. So the main function of the commutator, so which collects the current from the armature conductor, and the current in the armature conductor is a alternating one, and this alternating current is converted into DC current with help of the commutator. So commutator is the important one for converting so this AC signal into DC signal. The next one is the brushes and bearings. The brushes which are made up of carbon and copper, so which collects the current from the so commutator surface, and which is so drives the DC current to the external circuit. The next one is the bearing. So bearings is is used for the smooth rotation of the this rotor or armature. So these ball bearings are mainly used. So this is the main parts of the DC generators and their functions. The next one is the principle of operation or working principle. So how the DC signal can be obtained from the this output terminal of the so DC generator. So let us see. So this the how this generator works. Let us consider the two magnets such that the flux, a constant flux is produced from the north pole to south pole. Let us consider a rectangular shaped a coil or a conductor which is so rotates about its axis. So when it is placed in the magnetic field, so for off cycle, so the EMF induced in this conductor so is the alternating one. So during so first off cycle, so we'll get a positive off cycle. In the next off cycle, so we get a negative off cycle. So throughout cycle, so we observed so two off cycle. So one is positive off cycle, second one is so negative off cycle. So the EMF induced in the armature conductor is a alternating nature. So this in the case of DC generator, with help of commutator, this AC signal can be converted into DC signal or unidirectional signal. So this one is so with help of commutation, so the action of the commutation. So this is the commutator which convert the AC signal into DC signal. So for every half cycle, the direction of the current get reversal with help of the commutator. So first half cycle, the current, so the current through this coil is so positive half cycle. After next half cycle, the current get reversed, means the coil, so the coil under north and south pole get reversed. The current flowing in the external circuit is unidirectional. So means after every half cycle, the current get reversal. So with help of the commutator. So this is the action of the commutator or the function of the commutator. So the next one is the types of the armature winding. So based on the connection of the armature winding. So this armature winding is classified into two types. One is lap winding, second one is wave winding. So what do you mean by lap winding? So this in this lap winding, the armature winding is connected in a such way that the coil side or the conductor so placed on another conductor. It means so the coil side is overlapped on the another coil side. That's why this winding is called lap winding. So in this lap winding, so number of parallel paths is equal to number of poles. The number of parallel paths is denoted with A, and number of parallel paths is number of poles are denoted with P. So in lap connection or in lap winding, number of parallel paths equal to number of poles. So this lap winding also called parallel winding. So this lap winding is used for high current rating generators. So means for high current applications, lap winding is preferable. Next one is wave winding. So what is meant by wave winding? So in this winding, the armature winding is connected so in the form of wave. So that's why this winding is called wave winding. This winding is also called as series winding. So in this wave winding is so number of parallel paths is equal to 2, and which is independent of the number of poles of the machine. So A is equal to 2 in the case of the wave winding, right? Where wave winding is applicable. So wave winding is applicable. So where so high voltage is needed. So because of this reason, so wave winding is preferable for the high voltage capacity generators. So the next one is EMF induced in a DC generator. So we are going to see the, the EMF equation of the DC generator. So for that one, so let us consider certain parameters. So that is pi is equal to, so is called Weber per pole. So this nothing but so flux per pole, so which is measured in Webers, and Z is denotes the number of armature conductors, and this number of conductors are also counted. So number of conductors per slots into number of slots. By that one, we'll get a total number of armature conductor. And P indicates number of poles, where A is the number of parallel paths. So where N is the speed of the armature. So where E is the EMF induced in any parallel path, or so that is also easy is nothing but the EMF generated or induced in a generator, which is also equal to EMF induced any parallel path of the armature. So the average EMF induced per conductor, so which is given by d pi by dt. So d pi by dt, so for one revolution, the total flux, so the total flux cut by the conductor in one revolution, so which is d pi, which is nothing but the flux per pole into number of pole. So the total flux cut by the conductor in one revolution is equal to pi into p, and the number of revolution per second, which is given by so n by 60. The time taken for one revolution, so which is so reciprocal of so number of revolutions per second. So that is nothing but 60 by n seconds. So according to the Faraday's law of electromagnetic induction, so the EMF, the average induced EMF per conductor, so which is given by d pi by so dt, so which is nothing but so pi p divided by 60 by n, so which is nothing but so pi p n by 60 volts, right? So the EMF generated per path, or the EMF generated the total EMF generated in generator, so which is given by the EMF generated per conductor into total number of conductors per parallel path. So each parallel path, so this is given by Z by A, so which is nothing but pi p and Z by 60A. So this is the derivation or the EMF equation of the generator, general EMF equation of the generator, which is given by pi p and Z by 60A. So for lap winding, so we know that, for wave winding, so we know that for wave winding number of parallel paths equal to 2. So by substituting A is equal to in this EMF equation, so we'll get pi p Zn by 120 volts. And let us say, so when generator is connected in lap winding, so in lap winding we know that number of parallel paths equal to number of poles, that is A is equal to P. By substituting A is equal to P in general EMF equation, so such that we'll get the EMF generated in lap wound generator is pi Zn by 60 volts. So this is the EMF induced in the DC generator. So later we'll see some problems on the problems on EMF induced in a DC generator. So the next one is the armature reaction. So what do you mean by armature reaction? So the armature reaction is nothing but the effect of the armature flux on the main field flux is called armature reaction. So means, under load condition, we'll get a armature flux. So this armature flux effects on the main field flux. That's why this one is called armature reaction on main flux. So this is nothing but the armature reaction. And this armature reaction takes place under load condition. So whenever generator is loaded, armature reaction come into action. So this armature reaction shows two effects. So one is called demagnetizing effect. Second one is called cross magnetizing effect. So what is meant by demagnetizing effect? So demagnetizing effect is nothing but there is a reduction in the main flux. So this is due to demagnetizing effect, there will be reduction in the main field flux. Due to that one, the terminal voltage decreases. So this is the main reduction in the this generated EMF or terminal EMF is mainly because of the demagnetizing effect. The second one is called cross magnetizing effect. So due to this cross magnetizing, in which the main field get distorted in the air gap. So due to the cross magnetizing effect, the main field get distorted. So this due to this distortion in the main field, due to that one, there is a sparking takes place at brushes or surface of the brushes. So we'll get sparking. So because of this one, these are the armature reaction is somewhat reduction in the main generated EMF, and at the same time there is a sparking problem or commutation problem. So in order to reduce this one, let us see how the armature reaction takes place. So this one is, first is mainly because there will be reduction in the generated voltage. This is the worst one. The second one is this because of armature reaction. So this sparking takes place at brushes. So let us study how the armature reaction so takes place. So for that one, let us consider three cases. So in the first case is, so the field winding is so unenergized. So let us see, the only field windings get energized and armature winding get so is unloaded. So means there. So first we are generator is not loaded, and only we are considering the field winding is energized. So with DC excitation such that, so whenever a field current is passes through the whenever field current is passes through the field winding, so according to the thumb rule, the magnetic flux is produced. So that flux is produced from the north pole to south pole through the, so this one is through the this air gap and this armature. So this flux is a steady flux, or the flux is uniform. So the line joining of the north and south poles we called so polar axis. So this axis also called direct axis. So whereas the axis which is perpendicular to the this polar axis called geometrical so neutral axis. G called GNA, geometrical neutral axis, which is perpendicular to the polar axis. And so another axis is there. So this MNA, so that is called the magnetic so neutral axis. So the axis along which, so the EMF induced in this. So when a conductor is placed along this axis, the EMF induced in this, so this conductor is zero, then that axis we called magnetic neutral axis. So under no load condition, the magnetic neutral axis and geometrical neutral axis get coincide. So this will get so the lies in the same plane. So these two lines are same in the plane under no load condition. So let us see the second case. So that is, in this case the field winding is get unenergized. Only we consider the, so this armature current. By considering armature current through the armature conductor. So when the conductors, so these conductors which are placed so under north pole region denoted with the cross mark, the conductors are placed under south poles are denoted with so this minus symbol. So means minus or dot the symbol. So mean, so when current passes through the this conductor, so this conductor according to the thumb rule, so the flux will be, so when a current carrying conductor produce the magnetic flux, so which is flows, so this will flows, so depend upon the current direction. So when so current is flowing into the conductor, the magnetic flux so flows in the, so this fingers direction. So this minus or dot denoted conductor indicates the current upcoming conductors, current through, so means upcurrenting conductors. Under that condition the current flows so in downward direction. So when armature conductor carries the current, under that condition the magnetic flux will flows so in, so perpendicular, so or downward direction. So this is called the FMA. So this the armature MMF, so which acts in, so perpendicular to the, so perpendicular to the main field flux. So third case, let us consider the, so means this is a practical condition. So that is condition we consider the both cases, means the field windings get energized and the generator is loaded with some load. So under that condition, so we'll get a, so due to the field windings we'll get a the main field, due to the armature current, we will get a armature flux. So due to the, so under that condition, under load condition, the armature flux affects on the main field flux. Due to that one, so this magnetic flux get distorted, and so this, the brushes is shifted, so in so this right hand side, which is nothing but a generator, so rotating direction. So whereas this one is opposite, is called motor rotating direction. So motor direction, so this is the generator direction. So under this, when so rotating brush is shifted in, so this mn axis, so which will so rotates in a generated direction. Under that condition, brushes are shifted in generated direction by making angle, so theta. So under that condition, so we'll get two effects. So one is the demagnetizing effect, other one is cross magnetizing effect. So due to that one, the resultant mmf will be produced. So because of this armature reaction, so we observed the two things. One is there is a reduction in the terminal voltage. Second one is the commutation problems, that is sparking takes place at brushes. So this can be neutralized. So the armature reactions can be neutralized, so with help of, so two things. One is called so compensating winding, other one is interpolar winding. So with help of compensating winding and with help of so interpole winding, the armature reaction can be reduced. So this one is the reduction of the effect of the armature reaction. So this first case, so with help of compensating winding, so armature reaction effect can be neutralized. So how? So armature reaction can be neutralized with help of compensating winding. So let's see. So in this one, so this the pole core. So this one is the this. So pole, so this arc, so we called pole faces. So under this pole faces, holes are made. So holes are made. In this holes on either side of the, so this pole, so this is pole faces. In this pole faces, holes are made, and compensating winding is placed in this pole faces. So this compensating winding is so connected in series with the armature winding in a such way that the field flux, so the current flowing in this, so this compensating winding is quite opposite to the armature flux in order to neutralize the armature flux. When a compensating field winding flux neutralize the armature flux, under that condition the armature reaction can be reduced. So this compensating winding is connected in series with the armature winding. And the second one is the interpolar winding. So this interpolar windings which are placed in between the so main two poles, so that's why these poles are called interpolar. So interpoles. On this pole, windings are provided. So this winding is called interpolar winding. So this winding is connected in series with armature winding such that the current flowing in the interpolar winding is quite opposite to the armature current. Due to that one, the flux produced by interpole winding will act in opposite direction to the armature flux. So under that condition, the armature flux get neutralized by this one. So the sparking takes place at brushes will be minimized, and the commutation problem will be reduced. By that one, the commutation can be improved. So okay, thank you.